morning, everybody, and welcome to this workshop on how to motivate consumers to bring back their e-waste, and so that we can actually, as an industry, take them back and do something useful with them. Here's the title. So what is the agenda? First, we will introduce you to an EU-funded project called DiCE, Digital Health in a Circular Economy. And then we will move over to the heart of the matter. We will have Renee talking to us on how to engage and approach audiences to make sure we get small e-waste back. And he will also present consolidated outcomes from what we call sustainathons. These are hackathons for sustainability purposes. And then we will have Daniel from Grin, a Norwegian company that is really focused on getting smart collection boxes in place to, again, motivate people to bring e-waste back into circulation. And we'll end with some conclusions hosted by James from the WE Forum. So what is DiCE and why are we doing DiCE? The use of digital healthcare devices has been exploding exponentially over the last years, not only in the medical sector as such, but also through wearables such as smartwatches, where you have more and more medical applications that will monitor your health in different ways, from counting your steps all the way to looking at heart rate, for example. This innovation has enabled a lot of positive outcomes in terms of patients' benefits. We will have patients that will become more empowered by owning their own digital health data, being more motivated to take their own healthcare pathway into their own hands. And if we look at, for example, use of wearables in clinical trials, we also see that we can develop more diverse clinical trials by also connecting to people in more remote areas. So a lot of positives that we can state. However, this also comes at a cost of e-waste. And you'll see here some of the numbers from Deloitte, where we see this increase between 2021 and 2024, where you see that the amount of wearable medical sensors and devices has almost doubled over a prospect of 3 years. So that is quite staggering. And obviously what we do see is that these devices have their own problems. We know that of these devices that were placed on the market in Europe, only a limited amount is being reported as collected. We see that 54% of all electronic waste is collected across Europe. But if we look at small appliances under which some of these medical wearables fall, this drops down to a much, much lower number. And also yesterday at one of the plenary talks, we heard about this staggering low number of 17.4% collection rate globally. So clearly a lot of room for improvement there. And it is of increasing concern because, as we are here at the World Resource Forum conference, we all know that these devices and electronics have valuable raw materials that are essential to the EU economy. But as was also highlighted, we also have, for example, plastics and metals that are of a very high grade for pharmaceutical or medical device applications that could be recovered and recycled. We do have the clear expectation from the Commission on the EU Green Deal and the Circular Economy Action Plan to drive the entire European economy towards a circular one. For healthcare that has specific constraints, we cannot use your average post-consumer recyclates in our products due to variability in quality, for example. So we need to come up with something clever so that we can have that sort of guarantee on quality in those devices and keep that quality going and going for a closed loop. Unfortunately, that closed loop is not existing today. Many of these devices end up in landfill or are incinerated, so there's a lot of leakage there. They are also designed for single use from the get-go, so that poses a lot of challenges as well. So what we would like to do in DiCE, or what we are doing, I should say, in DiCE, is really ensuring that we can extend the lifetime of these medical devices as long as we can by developing and piloting solutions across the entire product lifecycle, going from design towards remanufacturing, reuse scenarios, also convincing the consumers, which is what we will talk about today. And then all of this have it underpinned through science, through life cycle assessments on different indicators, including social ones, which, as we saw yesterday in the plenary session, is absolutely critical. So we want, as I said, focus on the circular design. We want to look at how much of collection we need for these wearables to make it a sustainable operation, not only from a sustainability, environmental sustainability point of view, but also an economic one. There has to be some driver here, making sure we have the reverse logistics in place and also the refurbishment and remanufacturing processes. And finally, ultimately, at the end, also recycling infrastructure. What are the products in scope? We have categorized 4 product categories based on whether they are used at home or in a hospital, and whether they are subject to medical device regulations, which is quite constrained and has very clear quality expectations versus non-EU MDR, as we call it, devices. So that's how we decided on those product categories. Don't get pinned too much on the products themselves. They are use cases for their specific category. We are testing all of our strategies, including the nudging ones, which we will be discussing, and the collection strategies, which we will be discussing going in the rest of the presentation, through 5 healthcare systems across the continent. Why? Because we want to capture any geographical, cultural differences that may exist, and we really want to build up the ecosystem with the authorities and healthcare systems in these clusters as well. Because if we really want to drive that circular economy transition, we have to work together with all the operators across the entire value chain. So whatever we do in the Belgian region, we replicate in Spain and in Slovenia, which are the 3 main cluster areas, so that we can really get that insights across the different parts of EU, and by extension want to leverage that also outside of EU, obviously. We also have pilots in Norway, and Daniel will also talk about that, I hope, as well as running pilots in Germany at the later stage, where we want to really go for a large-scale testing of some of our solutions. So what are the expected results that we want to generate from this program? We want to have a replicable model for the digital healthcare industry that will enable moving from the linear system we have today towards a circular one going forward. And as I keep repeating, if we can pull it off in the healthcare sector, which is one of the most regulated ones around, then anybody can do it. And there's absolutely no excuse for any other sector not to go on this transition. So we hope that by showcasing this, we can convince any adjacent sectors to do the same. And this ultimately will allow for the widespread reuse of these products, recovery of those valuable components and raw materials, leading to increased resource efficiency while contributing to pollution prevention as well. This is a 4-year project. We had just have finished year 1 or are finishing up year 1. We have generated a lot of interesting insights. Some of them will be shown now. We have an additional workshop this afternoon where we will focus on design and business modeling as well. We have quite a lot of organizations in the consortium across 9 different countries, really cross-cutting across the entire value chain of the healthcare sector. And we will conclude in September 2026. Already in outreach, perhaps for the people in the room, we will have a major stakeholder event at the end of 2026, to which you are all cordially invited already today. So already put it in your agenda for 3 years. It will be in Brussels, so that is also known already. So with that, I'll go over to the more interesting piece from René. René, the floor is yours.
Thanks a lot. Thanks for the introduction. Yeah, welcome everybody. I like always to start with a bit of a game, questions, of course, and like to ask the audience and those who are not here but are online. Please join us in the questions. We're talking about sustainability. We're talking about waste. We're talking about e-waste, and we did some work on that, how to motivate people to drop their batteries. But I'd like to know before who actually does drop his batteries at the appropriate deposit site. So if you go to on your mobile phone, you can do it at home as well, or scan the code. and you will get a first question. Give you some time to start us up. I'll follow the audience here. I can't see what's going on online, but everybody online on the Mentimeter. Could I start opening the question? Yes. Yeah, could I do? All right, okay. Why doesn't this work? The backstage people are now discussing how to get next slide on. That's great because my pointer doesn't work. They're a bit nervous. Anyway, let me just, while you're trying to get the real question on the screen, a bit to elaborate on the issue. And that is, you know, we need to change, we need to, I won't say we need to, yeah, right, okay. There are some results. Ooh, surprising. Surprising. There's 25% never puts the empty batteries in the right deposit site. Wow, 25 to 50. So it's 5 out of, what is it? Percentages. It's 5 who do it only less. 6 is doing it well. There are 15 people are on the good side, but on the other hand, there are 16 people who are on the wrong side of the, which is a bad sign, which is an indication how serious we take e-waste, because batteries are e-waste, and how easily we drop them in the waste bin at home instead of bringing them to the appropriate deposit site. And that's exactly what we want to change in the DiCE project. It's related to medical e-waste, but it's also generic, can also be generically used. So there's a challenge. Thank you for this honest answers. Can I have the next slide? Okay. What we have been doing? We organize sustainathons. We collect information. So this one too far. One back. Oh no, sorry. We organized sustainathons. You can see sustainathons are about the same as hackathons. Hackathons are co-creation sessions with engagements of all stakeholders. I'll talk a bit more about stakeholders later on. A nudgington we invented that word because it is a hackathon in which you define nudging strategies for the return or reuse of medical e-waste. Nudging is a method to encourage or persuade someone to do something in a way that is rather gentle than forceful. You don't hit a person, but you make sure that he's moving in the right direction. And behavioral change is there very essential, and motivational strategies. How can you motivate people to change their behavior? The sustainathon was actually about the same as a nudgington, but it's more directed to sustainable behavior. And in all these things, playful interaction, and that's where Games for Health comes in the picture, because experts in Games for Health in playful interaction and the serious game application, etc. No real games with interactions that are used for nudging strategies. And you see an example here. This is a playful interaction. You use a basket to throw in the ball to get your separation of waste. So that's a simple example of nudging. There are some other nudging strategies. Those who are male, they know the left one on the top, which is to avoid that male are directing aside this and on the floor and directing it on the right spot. By the way, on KLM or Schiphol Airport, they found out a new one. Couldn't find the picture back, but they have there now. It's not a fly anymore, but they have a hole in one. We all know the situation with COVID, and there were some smart people from community organizations that, okay, we need to keep distance, but it's difficult to identify what's the distance of 2 meters or 1.5 meters. So they put circles on the green fields so people knew what was the distance and where to sit. That's nudging. The last one I've just recently noticed is based on the fact that at least in the Netherlands we have now implemented, I don't know, I think it's even European, a deposit or a return fee on plastic bottles. Well, at the university campus of Nijmegen, they made a side of the waste bin. They made a side panel where you can put the bottles on which you get a deposit. So I don't know who's going to collecting them, probably some poor students, but anyway, it should work. That's also nudging. It's anyway time of reminding people from, hang on, I have a bottle, don't put it in the waste bin. It needs to go in the appropriate process. So, and I get even money for it, so I put it over there. Sustainatons, what is it about? There's a lot of things in medical and in design issues. There's refurbishment, there's recycling, there's eco-design. We were focusing on collection. If you want to do refurbishment, if you want to do a recycling or want to do a reverse logistics, first you need to get it back. That's the first step. If you don't get it back, you can't do anything with it. So in the first Sustainatons, we were focusing on the nudging strategies, and we need people for that. We need manufacturers, probably, we need other people, but to get it back from the user, we need to focus on what are the user's perspectives. How do they feel? What are the reasons for, etc. A lot of whys. Just as I mentioned before, the stakeholder definition for the Sustainatons which people we used were patients, health consumers, users of electronic devices, medical devices at home, but also medical professionals and health providers like pharmacists, and also organizations providing and collecting medical devices. In some countries, like in the Netherlands, there are organizations like the Hartingbak and Welzorg, which do supply medical devices to people at home, not only wheelchairs, but also blood pressure monitors, which they collect if they're no longer used. So these are relevant. We didn't use them actually in the Sustainatons because it was outside of the Netherlands, but for the Netherlands, we could start talking with them. And of course, facility and logistic managers are very relevant in the whole system, in the stream of materials. That's the stakeholders we try to include in the Sustainatons. We had 3 regions for several reasons. We had Belgium, where we had the Sustainaton, we had Southern Europe, and we had Eastern Europe, because we assumed that there might be cultural differences between or amongst these countries. And but there are also some other things. You know, if it's 40 degrees Celsius in Spain, you will not walk to your pharmacist to return your whatever medical device. If it's snowing like hell or raining in Eastern Europe, then you won't do that. So that's not just cultural differences. There's a relation between culture and what is it called, the milieu, the environment. But of course, anyway, I wanted to make sure that we're not going to say, okay, the Netherlands or Belgium is one for all. No, it's not one for all. So we try to collect a lot of whys. Why? I could say, why do you not deposit your battery? But the question is why? What do you need? Why should you deposit your battery? I'm still wondering. We can have a lovely discussion. I'm really still stunned about the result on the first question. But anyway, there should be a why question now on my poll. But first, oh, it's in here. Yeah, okay. It comes when it comes. Okay, right. Okay, sorry. We did in Sustainatons, and we were absolutely astonished. We had we had exactly 495 whys. Okay, yeah, good. I was surprised to see myself. Okay. They're playing with the presentation. Anyway, I'll go on. We had about 495 whys collected during the Sustainatons, and people are answering the question already. Well, it's also a surprise. Technology, this is digital technology. All right, great. And one of the questions was why you return your electronic device to deposit the location. We collected 500, and that was the start of the next in the process to start design. But anyway, let's see what comes out here. What you answered, environment, obviously, very important. Recycling, environmental impact, no service can be reversed. Resources are depleting. This is interesting. Good, we stored it anyway. But you see, environment, recycling, and environmental impact are the main words in the questions. Oh, this is a nice one. Where is it? Okay, guilt. That's a nice one. That looks like the rebellions in the big results got from the citizens. It's good. It's guilt. It's intrinsic motivation. Okay, I won't go into serious games and designing, but guilt's intrinsic motivation. What we need to find is the intrinsic motivation for people to return there or to employ the nudging strategies. Could have a different section on that. So nice, interesting one. Great. Let's go back to the whys. Anyway, we got a lot here back. We got also feedback from the sustainatons. We got about 500, and which were all collected and listed. A hell of a job. They were all on post-its, but they were collected and listed. They were all put in a one big Miro board, whatever. And this is a list. I won't show you details, but this is a list that tells us it is because I want to do it easy, because it's not in my neighborhood, because whatever or whatever. 500 of these need some analysis. So we did coding on that. We coded them and resulted in some motivations, the main motivations for Belgium. And well, returning medical e-waste, it needs to make sense was one of the reasons. It needs to trust the system, which is relevant. You bring it back, but okay, what's going to happen with it? Wanting to know how to do it, wanting to do it right. Okay, you can read it. The red one is must be part of your routine. That's a relevant one, which we found out, which was particularly for Belgium relevant, obviously, for whatever reason, and wanting to rebel. There's some Belgians in the room, but that's probably the same who said guilt. In Slovenia, we found out some differences. These are the motivations from the Slovenian sustainatons. But funny, and I think it's interesting because we know that Eastern European countries do think a little bit different from the democracy, etc., than Western or Northern, wanting government to take care of, but at the same time distrust of the system government. It's perhaps something particular related to Eastern, and I won't say, I can say former communistic countries. It says a lot about culture. What happened there. So we have to realize that is relevant in the design of the strategies. And campaigning education is a bit closely related because campaigning and education means that you're told what to do. And Spain, I'll take one out, making it emotionally valuable, caring. One of my colleagues who might be online is available. He's from Spain. He's a rather emotional guy. And we know that southern part of Europe, Italian, Spanish, so they tend to be more emotional in all their habits. So that came out as well as some of the cultural differences. Coding the whys, I won't go in detail. This is what we got. This is a whole list of things, like having the infrastructure. What was the pointer? This is the point, having the infrastructure and knowing what to do, making it little effort, and we rated them. Are they concrete or are they abstract situations? Is that related to emotion or is it logical? Who will take action? Myself or the government? Action from myself, and is it permanent or is it only temporarily and ephemeral? That's one of the lists we created, and then we went into the co-design sessions with the stakeholders in the countries, again in the countries. And then there was again this why. So the list of the whys, the selected whys, were coupled with, for example, is this why related to collection, or a step further, reuse, redistribute, repair, maintain, refurbish, manufacture, recycle, the famous R's, and there's some. The number of R's is growing, I think, as we speak, because might be some new R's came up here to this World Resource Forum, but there is a lot of R's. That is also part of the design process. it's being collected, but what is also the purpose of the collection? Can we reuse it? And that's, of course, for medical devices, totally different. No, it's not, of course, totally different. It might be totally different for medical devices than for other consumables. Okay, what was the objective, of course, is to design a nudging strategy. There is this e-health product, there's a value, and there's a goal, and that results in a nudging strategy. Now we go to the concepts we got. This is the outcome of the first design sessions, which were sessions with the stakeholders, and with the support from the facility people and the managers from Leaker Lab, and of course the Games for Health team, which are creative, funny guys, crazy guys, and usually a lot younger than I am. Anyway, built on the whys, and I haven't elaborated on the whys, could be a different story. Built on the whys of value. It is a value for you. It's value for you to return it. It's personal. The device is personally, but it's also for me personally important to return it, and it's privacy related. Privacy, of course, plays an important role. We found this concept. Have a collection system where you can put your data in, and out of the results of the data, by some funny software, you get a nice drawing which you can hang on the wall and say, okay, these were my ECG results over the last 2 years or year, or these was my blood pressure result. Anyway, so, but you only get a complete picture once you put your device in a collection box. So you can do it at home, and then only when it's a collection box, you can get the full picture. So that's nudging. Of course, if you start half a picture having it home, you want to know the whole story. That's the concept of nudging, which came out. The other one was, and this is not a guy peeing on a graveyard. It looks a bit, that's the funny things our graphic designers do. This is a ceremony. You celebrate that you're healthy. You celebrate that you've finished your use of your treatment. It's care, it's also, and then you celebrate it, so you say goodbye to your medical device or your medication dispenser or whatever, and you bring that to a particular point. One of the other concepts which came out. It's value, it's care, it's also routine, and you get rid of the shit. But that's getting rid of it, but also you can use it in a different way. You could use, for example, systems which you can continue to use. So it's kind of repurposing, reuse in a different way. You know, the device isn't needed anymore, but it's still value to you. You can play with it. You can even create a community with it, and it has a second life. So you can play bluff poker with your fellows, your friends, or whatever. You say, okay, my blood pressure is now 90/10. It doesn't exist. You're dead if you're dead. But then is it true or not? You know, playing on that. Or my heart rate is, I don't know. I have to watch this one. It is cool. It's under 100. It's a Fitbit. My heart rate is, okay, come on, get back. Okay, my heart rate is 120. Bluff poker? Or what do you think is my heart rate? Shout it. Okay, it's only 98, not too bad. Playing bluff poker with your device. All right, and then, okay, I won't say anything more. Make it a present for the next patient. Because around your next patient might be a reuse. Make it a present, make it valuable, and it's also, I don't need it anymore. Please, here's my new device. Good. Second life community. That's related to the health dot, but you can use that for any other device. Or use that device integrated in a watch or whatever as a redesign it. It's the TU Delft comes now in the picture. Redesign it so you can also use it for your step counts or for your family or as a rehabilitation device. These all came out of, this is not things we thought about as game designers or some, this came out of these sessions. Another device was a pillbox, which is a very, I would say it's a very boring idea, but bring it to the pharmacist and it's very restocked and you can start using it again. Very simple, easy. done. Another one is, okay, you don't need it anymore, and it cannot be reused because there were drugs in it, and it needs to be cleaned because there might be dust of the drugs in it or whatever. So we need to redesign it, and we make it to a commodity item. We can put jewelries in it, we can put buttons in it or whatever. So the box is still being used and of value. So it doesn't get into the depository, it still remains in use. It doesn't influence the circular economy because, and then there's the next question. Oh, next one I have to put, okay. Good. Feedback on the next code essentials. I don't know what he means. Okay, Andre. Oh, I'm still there. Yeah, should I wait for the answers? I'm gonna wait for the answers. I'm now out of control, you know. He's moving, he's doing it. It's great. Love that. Yeah, all right. Good. Create a page. Yeah. I didn't want to say it. The gift box. Oh, it's going even up. It's impressive. I think the gift box will somewhere during the DiCE project being a winner. Because it came out, everybody was excited about that idea. Okay, devices also going up. You know, this is of course not an NS100 study, it's probably an NS30 study. But anyway, it's more than an NS1 study. And it confirms a bit what we got from the other sessions, because we had feedback after the co-creation sessions, we had feedback sessions as well. And the gift box was really appreciated. Actually, the gift box was even appreciated by nursing staff, because we did a workshop in the Netherlands during the so-called ICT and Health conference, and there were a couple of nurses in the room, and they said, this is a good idea, we should implement that. Good. Celebration and gift box are related, are associated, I would say a bit. Thanks a lot. Creating a patient is also creating a patient is more a message for Grin, our partner in the project doing collection boxes. Make a painting printer added to it. Okay, next one. Here we can do. I can do. This is what we got. Let's skip this one. Yeah. Oh, it's already answered. Okay. Connectivity. Choose the concept which you prefer. People are answering questions which I haven't asked yet. Good. Okay. Pay it forward. Invitation. This was the last question actually. Good. I appreciate that. Thank you. I'm done. No. Okay. Okay. We store that one, and we may have changed the answers later on. Can I get back to the presentation, please? Right. Okay, feedback on the next code session. What we did, of course, and I'll explain that, we had feedback on that, and yep, then we had an objective task during those sessions, the next co-creation sessions, and it was to develop and demonstrate solutions to design, collect, direct, reuse, and recycle. Because, you know, we had this growth in this wide variety of ideas, then you have to start pointing to a more concrete solution. And then there are collaborative connecting incentives that are easy to everyone to do, and making meaning more tangible through symbolism, values, routines, and rituals. That was the message the stakeholders got in the sessions. Of course, there is also a concept has a value. It is a value for effort, and there is a value for the user. And then there is this famous, well, it's also, these things happened after Boston came in the world with Boston Science. All things can be put in 4 squares these days. But this has a solution, a high value and a low effort, has the solution, a high value and or a high effort, or the other way around, a low value, low effort, and a low value, high effort. That's where we put all these ideas from the stakeholder, from the sessions in. And then we came to a step further, some more in-depth concepts for nudging. And that was the, and I'm not sure how much I'm having time actually. Am I already in time? Good, thank you, Els. Was, you know, you get a device from a hospital. When leaving the hospital, you know, because of what we're refocusing at, and you got a case there, So that's a bit with the surprise box, but you get a case from the hospital. You go home, you carry your bag with your dirty laundry, but you also get a case from the hospital. And in that case, there is this medical device, which can be large, small, whatever. And that case has a lot of tools to make sure that you return it if you not use it anymore in the appropriate way. It has it's called a care case. It has a date, because there's a date which when you finish your treatment or the use of the device, and it could have a number to call whether it's being picked up. You could use in the Netherlands, as I said, Wales or whatever. You can use in other countries, and we discussed that also a bit yesterday over dinner. You can use whatever DHL or other systems to collect it at home. You can set up a separate system, could also be possible. But that's anyway, it make it easy to do. That shows when the case needs to be returned. Stickers can be placed on the items so that the patient, on the items that the patient wants to return to. It might be that there are more in the case. So, you can put, it's concept. You can put everything in it, which you like. The care products are neatly organized, of course, and there's a manual with easy to understand instructions of using the electronic device. Well, the whole box has everything you need at home and also everything you need to return the case. And it's a concept. You can work on it. You can think about all kinds of other things. Pay it forward is again a present. So that value, making that product a value product for you is comes up anytime again, and they receive as a gift again. But no, and that's the box. You will recognize that if you don't use it anymore, the gift comes a letter, and the letter you can write from the previous patient who tells you, oh, do you have such and so on? It's not, but oh, you get this device now, so be happy, use it, and whatever. But also, so it creates value to the product, and creating value to a product, and it's a bit of is of course also relevant for changing behavior. Why did you throw away that question which you asked before, the simple battery just in the waste bin? It has no value anymore for you. But if a product has a value for you, you say, okay, I don't want to throw it in the basement. I want to make sure that somebody else is going to use it or whatever. That's very relevant. And medical devices do have a value. But if they don't, a blood pressure monitor device doesn't have a value. But a simple ECG patch doesn't have a value anymore. I would even say, take the worst case, a urinary taper with sensors in it. They are existing and they're being used in growing amounts, sensing the humidity, so you don't have to change your taper at the moment you haven't peed in it. Sorry for that. Background is a bit medical. That doesn't have any meaning for you. That doesn't have any value for it. It's dirty. So put it in the waste bin. No, because there are electronics in it. Copper and other things. There are people in this, one person in this room who love to get copper because they build a business going on that. It's a company Mirik in the Netherlands. Brilliant. Earn on the returned goods like gold, copper, etc. to sell that. That's where we need to do it. So how to add value to taper? That comes. And so if you use that with a pay it forward system, not in this case, of course, you cannot pay it forward to use taper, but add value in another way. This is an example for others, but then it's worth to think about it. At least somebody else can use it, or it has a value for something. Actually, I know I mentioned the tapers, but I know that these tapers are now considered to be reused in the sense that they remove the electronics from it and you put the electronics in a new taper. So no waste of resources. The World Resources Forum, no waste of resources. Now you just reuse it, take it out, throw the taper away, and then you reuse it again. So it has value for our planet. And of course, there's the big letter, the big famous letter. You can put that in the box or write a personal note for the next patient. This one is another concept. You get an invitation, talking about cardiac rehabilitation or other diseases. You may need mental support. So we can apply this to different diseases. You may need mental support, and so you get an invitation to join a session with other patients. But you can also elaborate that you can organize sessions with neighbors or whatsoever. But there you return the goods in that session, and it's being sure that it's being properly collected and back into the circular economy and system for reuse. And you also explain what the system meant for you. So it's all the value what you try to bring back. And then this is more based on the system, which has it's a smart pillbox which has associations with phone. You can combine it with phone, and there are lots of devices these days which are combined with phones. And your phone is to measure, to give instructions, to send you this annoying push messages or whatever. Because we don't really believe a bit in pushing messages, but if you're getting too many push messages, you switch it off. But you can use that to create a community. And as I mentioned before, so there was on the ideas was to use this pillbox for collective putting health or helps in it, but you can think about everything else. And you could join up with company organizations like HelloFresh or whatever. Picnic, I heard yesterday, to have it collected. So you start to organize to work together with another organization who does visit people at home. But you can also use it, and this is a funny one. This obviously came from our creative guys. You can also use it to put in your play cards and use it in a community with your family. So that is not throwing it away. This is we continue to use it and start playing board games with that. And there is a 999 games organization actually in the Netherlands, which supplies and promotes indeed more than 900 board games like Catan and Wingspan. So this is an example of reuse, but it's again value. Okay, what did we learn from this? And this, let's face it, this is just halfway. There will be new sessions. These concepts, there are more concepts, but we didn't want to share with them because then I'll start talking for another hour. These are some examples, and the lessons here is that value is, of course, very important for people. But the next stages will go continue to design, get back to the stakeholders, and start also eventually using them in the pilot study whether they work. Well, what is relevant, which we learned that the right stakeholders are highly engaged during the co-creation sessions. And thanks to the brilliant work of Lika Lab, we got engaged stakeholders. If they're not interested, forget about them. Because you need people who want to join you, thinking you, and start to understand you. What we were a bit surprised and happy surprised was that there was a high amount of shared responsibility for recycling, which came out of all of these whys. So we were also surprised about the overwhelming number of whys. If you put a group, 3 groups, which altogether were about the same as the audience in this room, together, you obviously, if you start brainstorming, you get an awful lot of reasons. We could have done it here, but that would take a day. You need a code. We use the, well, we knew the coding. Does anybody remember the name? Coding procedure we used? No, okay. We used the coding procedure and to code all these whys, and you need to standardize that. So you need just a bit of scientific background on that. And we also found that, though I mentioned them, we found that there are really not essential cultural differences in the results from the sustainatons, which is helpful because it means that you may generate an energy strategy, not one size all, but anyway, one size fits all, but one size fits at least a part of the people, which helps because you cannot design. Ideally, you have one energy strategy per person. That's the ideal situation, but it doesn't work. We know. But That's one side, because then you have the most effective nudging strategy you can ever think about that. The other ideal is to have one nudging strategy for all over the world, and that doesn't work. So you have to find something in between. That's a thank you. If you want more, don't call me, just drop me a mail. Do we have time for questions? Yeah, Els is not. Yeah. How much time do I have, Els, left? Sorry? For me? Oh, it's surprising the amount of time. Any, well, I don't know whether there's any online question. No? Are there still people online, or they're hacked off? All right, okay, surprise. Any questions from the audience here? Yeah, Virginia, right.
Yes, hi Renee. Very nice presentation. Nice to see all the suggestions. I think just on the very last point you gave, that actually sparked a question in my mind. Maybe some combination with collecting our personal data and understanding our personal behavior. And there's so many ways to do that, I think, through our phones, etc. It's a way to actually understand our intrinsic motivations, because, for example, Netflix, Facebook, Twitter, Instagram knows exactly what kind of content I want to see, and therefore from that it can derive, in essence, the kind of person I am, what I like to see, what motivates me. So maybe some combination with that actually will help to give a more personal nudging strategy per person.
Excellent point, Eugenia. You could get part of artificial intelligence integrated. That's, then you have an automatic designed nudging strategy. Okay, ideally. However, privacy, and we're talking about medical devices, and these are actually more sensitive than your mobile phone, which I have no. I've given up, because I know my mobile phone and my Google Analytics tells exactly what I'm doing. Actually, based on Google Analytics, it could identify the ideal deposit spot for me. They know where I'm going with Google Maps, and I go every week to a particular shop. So for me, they're the deposit point. And if you could have a large group of people, you can also say, okay, for a whole village, that is the ideal collection point, by using Google Analytics. Right, yeah, but for medical devices, it's a good point. And somewhere down the road, it might end up in, if you're talking about simple devices which do not record data, but electronic, or like patches or ECG patches, yeah, it might be interesting to get that information collected. Yeah, good point. But privacy is still an issue. Okay, good, thanks. Any more questions? No hands raised. Okay. I should ask that question again about the batteries, but then let's not do it again. But let's raise hand. Who was scared about or surprised about the fact that there are still a lot of people who do not return their batteries, empty batteries, to a deposit point? All right, just raise your hand high. Don't be shy. There's about 5 who said, okay, very surprised about it. Yeah, I'm as well. Who will change it now, as of today? Okay, it will be. That's disappointing. It will remain the same. So my message did not come across. Okay, thank you, and good luck. Oh, yeah.
No, I was just wondering if that wasn't due to cultural differences, to bringing back of the batteries.
I cannot share. It's differentiate culture.
So,
yeah. It could be a next question, but it's only the audience here and online who answer that question. So I don't know.
No,
and it's privacy related question. So I cannot ask here who was it doing that, because you may not able to leave that room. So, and what is your culture? So yeah, good point. But what brings me to the point, there are statistics on this. And in fact, which country was it? I think it was England, where they had the highest rate of deposit of empty batteries. And I think that the Netherlands was not doing that good. And there are some statistics on the internet on that. So there is the data. And if you see that, that's actually pretty bad, because batteries are bad for our planet if they not deposited some in an appropriate way. There's a guy from America is nothing. Yes, yeah, they're bad. Actually, and the reason is that there's not is that also there's a new law now that batteries manufacturers talk about redesign. Manufacturers do have to make sure that the batteries can be removed from your exception to electric toothbrushes. Yeah,
Yes, that's
yeah.
right. So indeed, there's now the new battery regulation that has been voted over the summer, where there's a clear design requirement on removability of batteries, either by the end user for consumables, but potentially also due to professional use if there's a safety concern. What was indeed striking is that electronic toothbrushes were exempted from that. Was one that was named because of the risk of obviously the water coming into contact with the device. But indeed, that's now a requirement going forward across the EU.
Yeah,
Absolutely.
yeah. That's one of
And there
the-
was no exemption for medical devices such as we are discussing here, which was as surprising as the electronic toothbrush exemption was.
Yeah, that's a good point. Yeah, it's great. Yeah, there's a lot of regulation coming up, which is forced changing of behavior. But let's talk in the Netherlands. We just had this implementation of the 15 cents you get returned on tins. And I'm living in a street where there are a lot of schools, children are passing, and I've noticed the difference. I used to clean the road about every month and picking up about 20 or 15 tins. School started, I haven't seen any tin yet. Probably collecting it, putting it in a collection, getting the 15-cent return. So that's it's extrinsic motivation, but it seems to work as well for these kind of devices. But for other devices like ECG patches, as I said before, you cannot ask a dime for an ECG patch if it costs you only €1 to have it returned in a proper way. Okay, no more questions. Good, then I hand over to Daniel, who's going to tell us everything about these collection systems and boxes. Good. And take the message with you, make it so that you can print a image, a graph. Good luck.
This thing sounds good. So I'm going to talk about smart collection of medical devices, but I could also put in brackets that the technologies and the solutions that I'm about to talk can also be applied to other devices. So small electronics and e-waste in general, and yeah, many different types of products. Yeah, I'm going to go through a short introduction, background about myself and the company that I work for, show you the first collection boxes that we are going to use eventually in DiCE in these 3 different countries to collect medical devices. Talk about smart collection in general, and a little bit about the vision, how we envision the pilots in DiCE to look like. I am Chief Business Development Officer in a company called Grin. We are a relatively small startup, still quite early phase, and we were founded in Norway, in Oslo, about 5 years ago. The whole reason behind Grin and why we started a company was this realization that if the world is going to reach any environmental target, whether it's related to CO2 emission, biodiversity, plastics in the ocean, the world has to become circular, much more circular. It's kind of the root cause of most environmental problems. And in order to become circular, there will be a need for new technologies and complete new infrastructures, basically in every industry, in every sector. So a little bit, if you look at the car industry, now you see electrification of the car industry is kind of gaining a lot of momentum. In order to reach that, you need battery factories, you need chargers everywhere, you need you need to produce electricity, you need ways of distributing electricity, you need digital applications for car users to be able to charge their cars and make it accessible. And I think in the circular economy space, was this tendency to focus on small pilots, at least in Norway, where we come from. There's a lot of pioneers developing small pilots, trying out new circular solutions, zero waste, grocery stores, often quite small. So there was kind of what's been lacking in the circular economy space is this really sort of larger scale thinking. What kind of technology and what kind of infrastructure is needed to really bring circular solutions up to scale and volume, which is what we need. So that is why we started GRIN. And what we ended up focusing on is smart collection systems. So we would make smart collection systems for the circular economy, helping any company or organization who have a circular product to get it back from consumers. Anything from reusable packaging to consumer electronics or medical devices. And the reason, of course, we want to go from this linear society that we have today. 90% of all material is not cycled back, and move it into this direction. And this also sums up pretty much what we are doing in DiCE. So we've gathered stakeholders throughout the entire value chain of the medical device, for these medical devices that we're working with, and we are trying to develop and come up with such a circular system. Now, for any circular system, you're always depending on having all these stakeholders together. That's one of the big challenges. But what we do specifically then is this part. So being sort of the collection point, we providing the hardware to collect a product might sound trivial, but it is kind of it is the connection between the consumer and the circular system. So you provide, you make it very accessible to return a product, and by also incorporating digital solution and software into our technology, we enable a lot of incentive schemes, nudging things that I will present a bit later. But the core of the problem is that you can design a product that is, it doesn't matter how recyclable a product is designed, how reusable it is, if you don't get it back from the consumer. So it's a key problem that needs to be solved for any circular device or any circular product, consumer product in general. You need to get it back. It needs to circulate as much as possible. If it doesn't circulate, then single-use products might even have a better environmental footprint. Smart collection. So what is it that we do? How does a smart collection system look like, or how does our smart collection box look like? So we define it as something that has, or we have defined it, we have designed a product that has sensor technology. It's equipped, the box that we have, it's equipped with sensors that enable us to detect and identify and validate what is returned. It is always connected. It is connected to the mobile network or the local Wi-Fi network. So it's always communicating. We're sending data about what is collected up into the cloud, where we make sense of that data and send it to those who need it. We provide APIs that enables us to connect this collection box to other third-party applications. So it could be the logistics operators in operating the reverse logistics for a circular value chain. It can be the local staff that needs to know when the collection box requires maintenance, for example. We have or are looking to, in the DiCE project, looking into adding digital locks to the collection box that enables access control. And that is something that has come up specifically as a need when you're working with healthcare, the healthcare sector and medical devices and pharmaceutical products specifically, because you have this certain, there's a level of security and control needed when you collect these types of devices, because they can be outright dangerous. They can pose a health risk depending on what kind of pharmaceutical substance that's included. There might be sharps involved. yeah, alerts, notifications, and alarms, over-the-air updates. You can always, when you're moving these, taking these circular systems to scale, it will be good to be able to have an overview of all the collection points and to have status. Just improves the operation of such a system. So that is why it's called smart collection, why we call it that. The first smart bins that you also can call them, prototypes that we have developed, it looks like this. So quite similar to the 3D renderings in the previous slides, but slightly different. So it's a metal box, steel box, very sturdy, secure. It's very difficult to break into. You will need power tools to do that. The black patch that you see there, that's the hatch where you return a product. And at the top, there is an LED grid with a camera sensor. This is an example of how this smart bin is being used today in a different project. So first two prototypes of this smart bin are now actually being used in a pilot in Oslo, where they are collecting reusable food boxes. So this is it's an office complex in Oslo, and the client in this project, sort of the owner of the office building, that organization, they wanted to get rid of single-use packaging. So each year they produce around 90,000 single-use packages in one canteen in that office building. It causes not only a big environmental footprint, but it actually causes issues in terms of logistics. It's a very narrow street where they have the office building. They have to manage the waste, quite large volumes of waste that needs to be managed each day. So circularity is of course primarily about the environment, but it also, the more we work with it, we see that there are a lot of other benefits by implementing different circular solutions. And I think this is a great example to show after René's presentation, because obviously you can see here that this is gamification and nudging in the flesh. So at the picture at the end there, they made a sculpture showing how many single-use boxes the employees in this office throw away each week. So every time one of the employees walk past the canteen, they see that sculpture and they are reminded about the impact of buying single-use products. And they kind of obviously that plays into guilt, among other things that when you talk about, when you see that, you realize, I don't want to participate. I don't want to contribute to this. And they've developed a cartoon character, a superhero. He's called Pantus. Kind of pant in Norwegian means deposit. So the whole system that they developed is a deposit return system. And they created this superhero as part of the storytelling, also playing on, with people's feelings, essentially. And the latest number that I heard before I traveled down here is that they are now seeing a return rate of 99% in this circular system, which is extremely good, I would say. It's not that many return systems that reach those figures. And typically when you talk about reusable packaging, as a rule of thumb, you need a return rate of more than 90% to get sort of a net environmental benefit of introducing the reusable packaging compared to single-use packaging. Obviously, because reusable packaging when it's produced has a larger environmental footprint than single-use packaging. So it needs to be used a certain number of times. And going forward in DiCE, we will find out how it will, in 1 year's time, you will see how this will look for the DiCE devices that we are collecting. I can also show you an example of how our collection box, how we intend it to be used. And this is only an example. You can configure it in many different ways. This is an example where a person, it's me in the video, where I'm returning e-cigarettes. It's just chosen those products. They were very similar to electronic medical devices, small. And we have shown how you can integrate the collection box with a digital service. So in this case, in order to access the collection box, to be able to open the hatch, you need to scan a QR code, and this QR code is generated through a mobile application. Now it can be set, you can, for example, put the QR code on the product itself, you can leave it open, you don't have to close it. But the value of having the possibility to do that is that we can then identify the end users, which can be, you might want to restrict who has access to and who can return a product. You might want to reward someone for returning something, such as in a deposit return scheme, for example. So then you need some kind of way of identifying the end user who returns something. But let's look. So yeah, pretty simple, easy returns. And that is also a sort of fundamental part of the design, is you need to make returns as easy as possible. And of course, there you have to have the mobile phone, but as I mentioned before, you don't have to use it. But returning something has to be easy. It can't be cumbersome for the end user, then the return rates go down. So the easier it is to return a product, the higher the return rates will be. And yeah, it's product agnostic. So there you saw the e-cigarettes, and what you also saw in the end of the video was when they were returned, you could see our image recognition technology being used, identifying the different objects. But the same goes if we would return a medical device, it would work just the same way. So it's only the size that matters here when returning something. So why smart collection? Why do we need that? The answer is you don't. There are many cases where you can just have a normal bin. You can see here in the conference center, for example, are placed around all over the building are different metal containers. They're just normal bins. You have 4 different or 3 different bins in different categories. But yeah, so that works. But it works to some degree, because I'm 100% sure that a lot of the waste that is being returned in these different bins around here, they don't contain clean streams of paper or organic waste. So you don't have that control. You don't get people won't follow instructions 90 or 100% of the time. So you get contaminated waste streams. And of course, when you're talking about medical devices and collecting certain pharmaceutical products, having collection, being able to collect clean streams, a certain device, a certain category can be very important. This is an example of when we started 5 years ago. We were collecting reusable shopping bags, working with a local clothing store. We made those ourselves out of wood, and it worked for a very small pilot. But what you quickly realize is, when you want to scale up these types of systems, you need a little more smartness. And the main reason is why you need smart collection. Again, safety and security. Control and automation, efficiency and optimization of logistics. And with that, I mean, when you have a whole fleet of this, say you have 1,000, if you imagine the future zero waste city, where you have thousands of collection points out in the city and an infrastructure, you would want to know when they need to be emptied, when are they full, so you don't send cars all around the city all the time to empty bins that are half full or haven't been. That is in itself causes a large environmental footprint. So when these systems scale, you do need these types of features to be able to operate environmentally friendly and financially sustainable system. We provide data. Increasingly, producers, OEMs are required to provide data on what happens to the products. Having a system where today, where a lot of a company sell a product and then you have no idea what happens with it afterwards. With a smart bin, you kind of get this functionality, you get traceability, and you can document what happens to the different devices and products. Deposit return systems, very popular and very effective. Financial incentive systems in general are super effective. And in order to implement those, you need some kind of verification of a product, that you need to be able to verify that a product has been returned in order to pay out a reward. Segregation and sorting, as I talked about before, a lot of health, safety, and environment in terms of both for staff, people handling this device, handling these products that are being returned. You need to be sure about what is in these bins. And you want to be sure that for certain devices, people cannot just access those devices. But in sort of a lot of what it boils down to have these smart collection systems, is what we see is that you get more. It's becoming a cost, a issue of cost really. And what I mean by that is, if you look at these pictures here, these are examples of collection or sort of return programs that are being piloted today in the healthcare sector. So it's the first one there up on the top there is from Denmark, where a patient is collecting devices at the pharmacy. They get a bag with them, some information that they are supposed to return them. And when they come back to the pharmacy a week later to pick up the new medicine, then they get a hold of a person working at the pharmacy. They take the bag, they return it. The pharmacist takes the bag, says thank you. If there's a reward, the person working in the pharmacy needs to give them a coupon or some bonus points or something. Then they would have to take the bag, go back somewhere at the back office area and put that bag with the devices in a bin and sort it. So that is quite a manual process of doing it, and it works for a limited pilot, a small pilot. Now try to imagine if you have 145 different devices being returned to this pharmacy. You would have a large queue with people going to the pharmacy only to return their products. The pharmacy would have to employ 1 or 2 people working nearly full time just to handle the devices, take them back and collect them. So in order to scale this, at some point you will need some kind of automated process for returning the devices, and make it more accessible for patients to return them. And that, of course, even though the smart collection has a higher cost than having a smart bin, it's a investment cost, but you would typically save the costs quite quickly compared to having paying personnel to do manual collection. But the same goes with returning it by mail, for example. So in the UK, there is a program where you can you get the package and you put the insulin pens in the bag and in the package, and you return them by mail, sort of prepaid. That works, of course, also for some devices, small volumes. If the devices are extremely valuable, then that works as well. But it's also very expensive. It's quite costly to send packages with mail. So having this smart collection is really a cost saver when you scale these types of systems. Going forward in DiCE, so this is a little bit how we envision these large-scale pilots that we're going to do, how they will look like in the end. So this is a map of Valladolid in Spain, and a kind of a snippet of the city. So how it would work is that we will identify optimal locations to place these collection boxes. And it could be, for example, a hospital and some pharmacies. Those are kind of, it's very intuitive to think about those locations, but there might also be other locations, your supermarket, really anything that makes it convenient for a patient to return something, anything that makes it a patient, you don't want to disrupt their day-to-day life. So in the next year, we will find out, we'll identify those locations in the DiCE project. And then we will put the collection boxes there and test it in the pilot. And of course, we've already designed these boxes. That they have the size that they have is not really a coincidence. So we have worked, for example, with local pharmacies in Oslo. This is an early prototype of the collection box. Just testing and making sure that what does a pharmacy from a pharmacy perspective, what would, you know, from a design perspective, what would they require to accept having a collection box standing outside in the pharmacy? And it's important to, you know, not only look at the end users and the patients, their perspective, you also need to consider the other stakeholders in a circular ecosystem. But it could be that you end up with only focusing on that, and when you go to different locations and you want to place them there, you realize they do not want them there, it can't be there. So it's designed to be easy to install. If you only use a normal 230-volt power socket, there's no really other installations you need to do. It needs to have access to the mobile phone network, and it's pretty much plug and play. And there should be room in most medium-sized pharmacies, and definitely in hospitals, to place these collection boxes. Another aspect that we're going to work with going forward, and which is one of the main challenges in the project, is how do you sort and categorize different types of medical devices. And this also has a lot to do with scale. So there's hundreds, thousands of different medical devices out there. So you cannot develop a system or various technical processes for each individual device. So you need to find a way of categorizing and bundling the different devices together in one stream. So here is, this is an example of our smart collection boxes, how they can be used. Similar setting as the waste bins that you see around in this building, where you, for example, have 3 different categories. And by, for example, tagging a product with a QR code, depending on the category, you can ensure that only a certain type of product will be returned in a certain collection box. Thank you.
Hello, my name is Ole van Allen. I come from the University of Applied Science in Norway as well. My question would be, what is the resource balance for this? Like, is it really beneficial in terms of, did you look in and analyze if it is beneficial to have the smart collection? Would it reduce the transport a lot in comparison to conventional collection schemes? Because it is quite resource intense to produce a lot of these smart bins, because it requires technology, it requires rare earths. So it would be interesting if it is in the end beneficial, and it would be also good marketing for your idea if it is beneficial in terms of saving resources, because you have maybe lower transport because you need to collect less, or you have better sorting system, you save on energy in these kind of regards. So that would be something that would interest me.
Yeah, it's a good remark, and of course we need to, you know, live as we teach. So circular design is something we are aware of, designing these smart bins, and we are designing them to be as recyclable as possible. So it's basically, it's the main component of a smart bin is steel, which can be recycled, and soon in the future we'll hopefully be able to source greener steel and recycled steel manufacturing these boxes. We also have a very modular system where all the electronics is put inside the box in one small container at the top of the smart bin. So it's very easy to remove all the electronics, to repair it. Of course, that's one thing. You want to make them, design them to be very durable, but also at the end of life, which will come at some point, it will be very easy to remove the different components inside of it. And it's also designed to be very robust, because there's no, if you look at the more traditional reverse vending machines that many people know from returning bottles and cans, they are quite big. They have loads of moving parts inside of them, which break down more often, and just in general contains more material and components. But yeah, hopefully in DiCE we'll be able to make some calculations on this as well.
Indeed, and I think that's part also of another work stream that we did not present yet, but where we look holistically on the whole reverse logistics to make sure that we do the right thing overall. So we would be calculating also the reverse logistics part as part of a life cycle assessment, but that's done by other people. And I don't know, Naomi, you have been mapping the value systems only for 2 products so far within the project, but I think this will be part of that. So Naomi, if you can.
Yeah, so it's going to be part of it. We've started with the 2 devices, but the long-term goal is to have all the value chains of the 4 products, and also the downstream processes are going to be considered as well.
So as a short answer, please follow us and you will see the outcome of this.
Thanks, Els, and thank you to Daniel and Rennie as well. I'm aware it's -4 minutes to lunch, so I'll be fairly brief.
Start late. We were.
I know, but it's still -4 minutes to lunch, so. So it's by way of a summary as well as some conclusions from some of the comments today. But as Els pointed out, the reason why we're doing DiCE is because of the huge increase in the use of these medical devices and sensors, and it's what to do with them at the end of the life and how we make them more circular. So that's the motivation behind the project. And what we will do is we're looking at circular design, the collection, of course, reverse logistics, refurbishment and remanufacturing, and the recycling of the devices at the end of their life as well. So that's what the project will cover, and we have these 4 products in the scope of the project. And Rene talked about the sustainathons, and he started with a question about battery recycling, and it just shows really that half the people in the room don't habitually recycle the batteries, and I think it just presents the larger challenge of the project. Small items of e-waste quite often get placed in the general waste, quite often get placed in drawers. It's not just medical devices, it's all e-waste, and it's something actually that the Commission is looking at, the European Commission is looking at the moment in its revision of the WE directive. How do they incentivize and how do they get people to return these small devices? And it's something that the work we're doing in DiCE can be transferred to other e-waste as well. So it's very interesting, the motivations that we've discovered in the sustainathons. And Rene talked as well about where we did them in Belgium, Slovenia, Spain, and the participants were a broad range of stakeholders with interest in the projects. And he talked about barriers, the motivations for recycling, and we looked at the motivations in the room as well. And mainly they were environmental and recycling, but a good one that Rene emphasised was that of guilt, and I think that's a really strong motivating factor for people to return items and do the right thing with them. And the co-design session, so we've worked as well on designing the nudging strategies that we will use in the project and testing the project. And we have these initial concepts for the nudging strategies that have already been developed. And it was apparent from the room that the gift box was the most popular, and it from what Renee said, it seems to be Renee's favorite as well, I think. So we're looking further into those, and we'll test them all, of course, and see what works best. Daniel then talks about smart collection and the design of these smart collection bins and how they will be used. And there was a good point from the back of the room regarding the environmental impact of the bin. And certainly, as Els mentioned, it's something we will look at for the in the project. And then we were in these pilots, so it's not just about where we place the bins, but how you collect them, how you arrange the logistics for returning these either to the manufacturer or to the recycling plant. So that's in a nutshell is what we're doing with the pilots. And finally, just a thank you for attending. And also, this project is very much the stakeholder consultation is very much ongoing, and we really would like you to join with us and maintain the communication. If you scan the QR code there, there's access to a page where you can join the project network, and we will keep you abreast of the developments in the project and invite you to contribute to consultations that we have. And I think that is everything. I'll follow us obviously on LinkedIn and Twitter as well. And we have a booth just by the coffee stands. So if you're here for the next day and a half as well, please come and join us. We have a challenge there where you can.
And yeah, exactly. You've gone to mention challenge.
Yeah. There's a challenge.
Yeah.
There's a challenge on the
game.
Games. A challenge on the booth to deconstruct and reconstruct a Lego medical device. So come and have a go at that. It's actually a competition. The fastest time will be awarded a certificate this afternoon at the workshop session that we have this afternoon here at the conference. So once again, thank you for joining us. I don't know if there's any further questions, any general points or questions anyone wants to make. No, okay. Well, thanks again, and enjoy the rest of the conference and the rest of the day. Thank you.